In this video, we're going to be simplifying numbers that have complex numbers in the denominator. So we're going to be rationalizing those. And to do that, we're going to be using a conjugate. So what is a conjugate? Well, a conjugate is a matching opposite, really. So if I have the quantity a plus b, its conjugate would be a minus b. So for example, if I had 3 minus the square root of 5, my conjugate would be 3 plus the square root of 5. Conjugates are used to rationalize complex numbers in the denominator, such as we have here. So in example A, we have 1 divided by 2 minus the cube root of 3. The square root of 3. So our first steps are the same. We're going to end up multiplying our numerator and our denominator by the conjugate this time. Not just the radical, but the conjugate. And the difference is because it has that minus sign as opposed to multiplication. So when we multiply our numerator, we'll take 1 times 2 and 1 times the square root of 3, which will give us 2 plus the square root of 3. Divided by, now how do you multiply conjugates? Well, there's a shortcut for multiplying conjugates to help save some time. So if our conjugate is a plus b times a minus b, the shortcut is simply to take the a squared and subtract it from the b squared, or subtract the b squared from it, rather. So as an example here, so you're going to find your a and your b for the first step, then you square them, then you subtract them. So let's put that into practice here. So we're going to start off by finding our a value. So our a value right here, so we're going to say our a value is 2. Then we need to find our b value, which is the square root of 3. Then we're supposed to square those values. So it says to find your a squared and to find your b squared. So we'll go ahead and we'll plug in our values. So 2 and the square root of 3. And 2 squared is 4. And the square root of 3 squared, well, that ends up making the square root and the square cancel out, which is going to drop down our 3. And then we're going to subtract those. So this was our first step, second step, third step. And 4 minus 3 is 1. And so we're going to take our 1 and put our 1 right there. And because it's a 1 in the denominator, that means that our final solution here will be 2 plus the square root of 3. Let's do another example. So here we have 8 divided by 1 plus the square root of 5. So we're going to multiply our denominator and our numerator by the conjugate, which is 1 minus the square root of 5. So to get our answer, we'll begin by multiplying our numerator. So 8 times 1 is 8. And 8 times negative square root of 5 is going to be a negative 8 times the square root of 5. Our denominator, we're going to go ahead and multiply our conjugate. So I'm going to go ahead and have you guys do this portion on your own. So go ahead and do the 3 steps, and let's see what you get for multiplying conjugates. So push pause, and then when you're done, push play, and let's see if you were right. So here, you should have found an a value equal to 1 and a b value equal to the square root of 5. Then, when you squared those values, you should have gotten 1 and 5. And when you subtract them, that gives you the negative 4. So we're going to take that negative 4 and put it up into our answer. So we're going to go ahead and rewrite that, and we're going to move our negative out to the front. So 8 minus 8 times the square root of 5, or rather, we should probably do it this way. It's a little bit easier. If we look at this, we see that 4 goes into this 8, and 4 will go into that 8. So because 4 goes into both of those numbers, or there's a number that all 3 of those numbers have in common, I can simplify. So negative 4 will go into 8, negative 2 times, And negative 4 goes into 8 positive 2 times, and negative 4 goes into itself 1 time. And so that is going to leave me with a final answer of negative 2 plus 2 radical 5. And that is going to be our final answer. Now, if those numbers hadn't been the same, so if we'd had 3 minus 8 radical 5 over 7, then I would be done because nothing reduces, and I would be finished. And so that is how you can use conjugates to help you simplify numbers with complex numbers in the denominator.